Hello and welcome everyone. Happy Monday. Our topic today is monitoring cloud security, where you'll learn about container security and OS Management Hub. You will also learn about CloudGuard, a security posture management tool, and threat intelligence. My name is Renu Bhatt. I'm a program lead for the customer enablement team here. And today we have with us Vinay Kalra and Amit Chakravarti. Both are cloud security specialists. We have some really interesting content lined up for you, so I would like to quickly hand it over to Vinay. So Vinay, please take it forward.
Thank you, Renu. Hi, everyone. Quickly, let me introduce myself. My name is Vinay Kalra. I am a cloud security architect here. We belong to the security specialist team of North America. Amit, can you quickly introduce yourself?
Sure. Thank you, Vinay. So this is Amit here, Amit Chakraborty. I'm a cloud solutions architect specializing in security. I help customers with various OCI security requirements and asks.
Perfect. And so today, well, first of all, welcome to part one of monitoring cloud security. And I hope that you can also join our part two, which will be taking place in about a month. But for today, here's what we're going to be discussing. Amit is going to start out with talking about OS Management Hub. This is a service that maintains and manages your packages, OS level packages and security bug fixes for Windows and Linux. Then I will go into CloudGuard, which is our security posture management service. And then Amit will end the discussion talking about container security, which scans for vulnerabilities of custom images within OCI registry. So Amit, please take it away.
Sure. So thank you, Vinay. So let's look into OS Management Hub and how it can help you in maintaining a secured environment. OS Management Hub is the next generation management solution for operating system environments. It provides a centralized management console to monitor and manage updates across your entire environment. So, OS Management Hub monitors available Oracle Linux and Microsoft Windows Server environments at scale. From a single view, you gain control of updates over your entire environment, reducing administration and improving efficiency. OS Management Hub is delivered as an OCI service. It can manage instances in OCI, supported third-party clouds like Azure and AWS, or on premises in a customer data center. OS Management Hub provides updates as they are made available by OS vendors. Available updates are subject to the vendor's OS lifecycle programs. The following OS versions are supported. For on-premises and third-party cloud, Oracle Linux 7, 8, and 9 are supported. For OCI instances, in addition to OL 7, 8, and 9, Oracle Linux 6, as well as Windows Server 2016, 2019, and 2022 are also supported. OS Management Hub uses an agent for managing and applying updates on an instance. The agent interacts with the OS content on an instance as directed by the OS Management Hub and reports data and results back to the service. The agent differs between OCI and on-premises or third-party cloud. OCI instances use the Oracle Cloud Agent to interact with OS Management Hub. You enable the OS Management Hub plugin for Oracle Cloud Agent to register it with the service. In the case of the on-premises or third-party cloud instances, they require a management station to act as a network proxy to communicate with the service and act as a local YUM and DNF mirror of Oracle Linux software sources, that is repositories. Only the management station directly communicates with the OS Management Hub, eliminating the need for your managed instances to directly communicate with OCI. Instances in your data center send and receive all requests and responses for OS Management Hub through the management station. When instances have a job to update packages or OS content, they receive the content locally from the management station, thus reducing the amount of bandwidth used for patching instances. All package transfers are local to the data center. And this is the consolidated view with instances in OCI as well as outside OCI. OS Management Hub provides an overview dashboard that lets you know how many security and bug updates are available that have not been applied in a managed environment, and a status check to make sure all managed instances are properly communicating with the service. OS Management Hub provides real-time reports that help you understand the status concerning your security patch compliance. It provides drill downs to security advisory information. From the reports, you can run the updates immediately or at a schedule straight from the console. And these real-time reports can be downloaded anytime. Now, OS Management Hub simplifies and helps automate updates and packages for distributed computing environments through a single management console. There are several levels in which you can manage instances. First, you can manage instances individually, and there are many actions you can perform at that level. You can view the instance details, check for and apply updates, install and remove packages, manage Oracle Linux 8 and 9 modules, run update jobs at a scheduled or recurring schedule, and do much more. Instances can also be managed as groups. A group is a collection of instances that you manage as a unit to align OS content. You can then perform bulk and management operations to maintain your company content standards across a set of instances. Now let us dig into management of Oracle Linux instances. Let's break down into some details on the OS Management Hub features. There's a lot of flexibility in which you can choose to manage, control, and customize how you want to manage your Oracle Linux instances. For instance, by software source, which is a software repository that provides packages to your managed instances. Software sources are a way for you to control what packages or kinds of update packages can be applied to your instances. There are several types of software sources. There is a default set of Oracle Linux repos that are provided. A custom software source is a user-defined software repository with curated content derived from other software sources. A versioned custom software source is an immutable, that is, it can't be changed once defined, software repository with curated content derived from other software sources that had been assigned version designator. Version software sources are used for managing content across lifecycle environments. You can associate these software sources with individual instances, groups, and a lifecycle environment that you define. There are flexible schedules you can customize to deploy, update patches at a one-time or a recurring schedule, or at a staged delivery across the dev, test, prod lifecycle. There are several ways in which you can manage instances. First, you can manage instances individually. There are many actions you can perform at the individual managed instance level. You can view the instance details, check for and apply updates, install and remove updates, and run patch status, that is compliance reports, that let you know how many security fixes and are outstanding for the instance. It supports managing Oracle Linux 8 and 9 modules and can run jobs at a schedule or recurring schedule. Zooming into the UI to manage instances, OS Management Hub highlights the total number of available updates for the instance and breaks down how many security and bug updates are available. You can search for and select specific updates to apply. You can drill down on specific security or bug advisory for more information. You can use the button at the top to create an update job to run at a specific time and update. You can also manage Windows instances. At the individual managed instance level, you can view the instance details, view updates and installed updates, see the details of updates, that is, for example, the knowledge base articles, reboot requirements, reboot uh, and, and so on and so forth, schedule and apply updates, and much more. So now let me walk you down the console, show you the software sources, profiles, Oracle Cloud Agent, along with the OS Management Hub plugin, etc. Basically the things we discussed until now. So here we go. So here you can see the OS Management Hub dashboard. You can see that the dashboard is actually showing you various information about what all security updates are there, the bug updates report, the instance activity report, and so on and so forth. Now, for this particular demo, I have brought two instances under its purview. So if you look into the instance activity report, it says that one of the two instances are not communicating with the service. Only one is there. So for example, if I actually click into that, it says that the first one is actually offline, and the second one is actually is the instance which is active, and it is communicating with the OS management hub. So that is fine, and we will actually go into the actual instances and have a look into the agent. So let me go back into the OS management hub overview section, the dashboard. Here you see all the security updates. So if you click into that, for each of them instances, it shows how many advisories, the security advisories are actually available. And similarly, you can actually do the same thing. If you go into the bug updates, you will actually see the same information, similar kind of information about the various bugs which are actually which have been detected by the OS Management Hub for those instances. Now, looking into the software sources, which are basically the repositories, and I have to actually go into the root compartment here. As you see, these are the various software sources which have been actually pulled into under the purview of which has been brought into the purview of the OS Management Hub. And but these are not the only ones. I mean, Oracle actually gives you a larger content. For our purpose, we have actually pulled in only these software sources, and 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 also let me look into show you guys about let's go into the instances. As you can see, OSMH was one of the instances which was active and communicating with the OS Management Hub. Now, every instance in OCI has a Oracle Cloud Agent, which has various plugins. And as you can see, OS Management Hub is a agent. There is a plugin for that, which helps you, which basically acts as the plugin, which acts as the kind of the agent, managing the updates and the patches for the operating system environment. And so this is the OS Management Hub agent, and this is the agent plugin which helps in communicating with the OS management service, the hub service. And looking to various and you can actually group. I haven't actually created a group, but as we saw during the presentation, you can actually group the resources, and so that the group of instances can actually act as a single entity, accepting various content, the OS content from the software sources, and so on and so forth, right? So and so I think. Earlier, Vinay was actually having a question on these software sources. Vinay, uh,
Oh,
you
that's
have a
correct.
question on
So I do have a question actually.
yeah.
My question is, I have a group that only has access to a specific compartment, and I noticed that software sources were at the root. How can I create a custom software source
Right.
within
Yes.
that compartment?
Right. So that's a great question. So what happens is that these are all Oracle supplied software content, right? So these are all Oracle supplied content, and when you actually pull in these software sources into under the OS Management Hub's purview, they're automatically placed in the root compartment. Now we know that the root compartment is a highly privileged. I mean, basically, you don't actually deploy OCI resources in the root compartment. So to come to Vinay's question, the answer is to actually replicate these software sources into your own compartment. And also, as Vinay was actually saying, that many of the administrative groups, they don't have actually permissions to act on the or rather basically access or act on this root compartment. So how would you do that? So the idea is that basically you select particular a software source and then you actually replicate the software source. So if you do a replication of the software source, here you see that it actually asks you which particular destination compartment you would like to actually replicate the software source. And that way, once this software source gets replicated, the administrators who are having access in that the mm, the destination compartments, I mean the compartments over there, the non-root compartment, they will be able to actually use these software sources. So that is that basically, and then you can actually go into the reports. These are the various security reports which it actually publishes, and going into the instances. I have to actually go back to that my compartment here, and let's see, and let's encrypt. And these are the two instances, and these instances I think we saw. It talks about the various packages are there and the jobs and the reports, and you can actually go and create an update job if you wish, and you can actually update either all. You can select. You can be more selective. You can actually select the security fixes or the bug fixes, or if you want all of them, and so on and so forth. You can also schedule them. You can either run these updates right now, or you can actually basically schedule at a future date, and you can actually make it as a recurring one. So that gives you an overview of the OS Management Hub. I mean, this kind of actually concludes my talk on OS Management Hub. Now, Vinay will continue with the talk on Oracle Cloud Guard. So over to you, Vinay.
Great. So let's talk about CloudGuard. For this topic, I'll be covering CloudGuard, and some of you may already be familiar with CloudGuard. It's been out for some time. Our discussion today will cover the basics of CloudGuard, as well as go over some new features. So CloudGuard is OCI's native security posture management service, and it does three main things. First, it examines your targets that you define. Second, it detects problems. And third, it provides you with a mechanism to fix those problems. CloudGuard also supports integration to external systems via OCI events. And having a single console provides for a bird's eye view for all things security. This is obviously helpful from a manageability perspective. So before we dive a little deeper, let's just review some terminology. Targets define the scope of what resources to evaluate. You can think of targets as components. So for those of you who are familiar with OCI IAM, components are just a logical construct where your resources reside. So the next terminology is detector, and a detector is a set of rules to be used to identify issues against a target. When it finds an issue, it surfaces that up as a problem, and the problem is basically the result of finding a potential security issue. And then we have responders, which notify and can act to correct the problem. So let's see how this fits into our life cycle. So once a target is defined, you will need to deploy at least one detector and one responder to that target. And once the configuration is made, CloudGuard will scan the target and use the rules associated with the detector to search for problems. And so when a problem is found, the responder kicks in and sends a cloud event, and if possible, remediates the problem. So let's take a look at a use case. In this scenario, we have an administrator that had either created a new bucket with a visibility set to public, or maybe that administrator modified an existing bucket and set the visibility to public. This is considered a security vulnerability, and the goal is to set the visibility to private. So here's the flow. So as I was saying, that we have an administrator that changes the bucket visibility to public or creates a new bucket with the same visibility, right? And now we're going to see the flow and see what CloudGuard is actually doing. So the end goal is to make a bucket private, because this is considered a security vulnerability. So a detector type is called configuration detector, and it has a rule called bucket is public. Upon the scan, the rule is triggered and a problem is created as critical level. The responder then checks to see if the cloud event is enabled, and if so, sends the event to OCI events, which can send a notification or maybe invoke some code via OCI functions. The responder also checks to see if the remediate rule, make bucket private, is enabled. And if so, this allows an administrator to remediate the problem by giving CloudGuard the permissions to change the visibility to private. And that's the flow. Thank you. You can access CloudGuard by going to Identity Security, CloudGuard, and Overview. When enabled, you will see the Overview page. And I will be demonstrating this in the demo. Let's take a look at detectors. Detectors are at the heart of CloudGuard, and there are 4 types: configuration, activity, instance, and threat. The example that we saw earlier, we were looking at a configuration detector recipe. And there are also 2 types of recipes. One is Oracle Managed. These are the out-of-the-box detector recipes, and these recipes cannot be modified. And then we have our user managed recipes. These are cloned versions of Oracle Managed recipes, or they may be even cloned from existing user managed recipes. User managed recipes allow you to make changes. For example, you can enable or disable rules. You can change the risk level. You can also change conditional parameters. Also note from time to time that Oracle may add or change rules within the detector as a feature release or a fix. Now, one question that we get a lot from customers is, well, if I've already cloned my recipe and a new rule gets in place, what happens to my existing recipe? Well, Oracle does 2 things when this happens. One is that we notify the administrator that a change is taking place. And second, all changes will be propagated to the cloned recipes. So you automatically get the changes. There's no manual process. So just like with detectors, responders can also be cloned to allow for changes to the recipe. But responders are a little bit different. They have 2 types. They have the notification type and they have a remediation type. The notification type basically sends the cloud event to OCI events. And the remediation is basically an action to apply to an existing problem. And you can configure remediation to either happen automatically or manually. By the way, the default is manually. Next slide, please. So let's take a look at the, let's take a look at the problem lifecycle. So now once you've configured targets and applied at least one detector and a responder recipe, we're going to start seeing problem servicing. So when viewing a problem, you'll have 2 or 3 options. You can respond by resolving or remediate the problem or dismissing a problem. Both resolve and dismiss are manual processes, and remediate will let you apply if there's a corresponding rule. So remember our use case, the make bucket private? That was a responder rule, and there was a corresponding detector rule that said, is bucket public? Also note that if you select resolve or dismiss on a given problem, but you don't actually resolve the issue, CloudGuard will update or recreate the problem upon the next scan. The takeaway here is that you either resolve the issue Well, you change the baseline. Remember, the goal is to reduce the number of false positives so you can actually focus on security issues. Next slide, Amit. So that covers the basics of CloudGuard. However, CloudGuard is expanding to be a unified security platform, and instance security is the latest addition to the CloudGuard family. So CloudGuard Instance Security basically collects and aggregates important security information about compute hosts, such as security alerts, and security alerts actually propagate to CloudGuard problems, but it also checks for vulnerabilities and open ports. Instance security also has the ability to detect suspicious processes, open port creation, and script execution, which requires operating system level visibility. Instance security provides a new Oracle managed out-of-the-box detections and the customer managed queries for threat hunting use cases. So this provides a bird's eye view of CloudGuard problems and OS level vulnerabilities. Now, I mentioned vulnerabilities and open port scanning. Some of you may know that this was our vulnerability scanning service, VSS. However, now this will be part of Instance Security in CloudGuard for a unified experience. Instance Security recipes are in line with the MITRE ATT&CK framework. Instance Security is also integrated with logging services, so you can actually configure to send your raw data to a SIEM for further analysis. And we support Windows and many flavors of Linux. So administrators or maybe your internal SOC teams can also run their own queries on compute instances on a periodic or ad hoc basis. This provides real-time detection for any vulnerability exposed via the instance. So how do we do this? Instance security is built on OS Query, which exposes the operating system data as high-performant relational database. OS Query is performant, open source, multi-platform host agent that lets you gain visibility and insights to your fleet. After you run a query and are happy with the query results, you can actually schedule the query to run at a certain frequency. All right, so let's talk about threat detection and how it's integrated with CloudGuard. What is it exactly? Here's the definition from Gartner. What does it mean by evidence-based knowledge, and where do we obtain this knowledge? The data comes from many sources within OCI. The key is that we need to correlate and find patterns to determine if something is a threat or not. So in order to do this, there's two pillars that we've got to focus on. IP addresses, executable hashes, URLs, they're all examples of indicators. But that's not enough. We need to understand techniques and tactics used by bad actors in order to really provide legitimate security concerns. One way we do that is through threat intelligence feeds like the MITRE ATT&CK. The MITRE ATT&CK defines known techniques and attack vectors patterns. So monitoring and preventing threats is much different than, say, monitoring a configuration's bucket visibility. How do I detect threats? Oracle Threat Intelligence Service aggregates threat intelligence data across different sources and manages this data to provide actionable guidance. Aggregated threat intelligence data comes from open source feeds, threat intelligence providers, Oracle expertise, with overall confidence assessment based on source, frequency, and quality of sightings. So how do I prioritize this? In order to prioritize, we need to understand what it is. Is this a false positive? Is this a cyber attack? Is this ransomware? And in order to fix the issue, we must understand the scope. The Threat Intelligence Service provides a list of sources where the indicator was found. As we've seen now, prevention comes from CloudGuard detector responder settings and best practices to help monitor and remediate problems. Let's take a look at the UI for a Threat Intelligence Service. So within the console, there are two areas where we actually expose the intelligent data. The Threat Intelligence Service is one of them. Threat Intelligence Service manages disparate feeds and creates a simple confidence score for each indicator to reduce false positives. while providing transparency into the source for support incident investigation. As you can see here in this picture, at the top portion is basically the header information about the indicator, and this indicator happens to be an IP. And the bottom portion of the screen is your actual sources. This is where, what source did I actually see this indicator? And then we have a score, a confidence score, that gives you, the maliciousness of the indicator. The second area where we expose threats is via the threat detector recipe. The detector exposes any potential rogue user in the system. Once this detector has attached to a target, you will need to set up permissions to use a threat intelligence service. So this concludes the slide section. Let me go ahead and do a quick demo. Let me log in. So I'm going to walk you through the UI, and I'm going to walk you through as if I was going to set up CloudGuard for the first time. So when you come into CloudGuard, after it's being enabled, you will notice that you've got some widgets here. We've got some scores. It's set to good. You have a risk score. That's a pretty high risk score. And then you've got a couple of widgets where you can drill down into the problem. So if you click on any of these things, you'll see just a list of critical problems, etc. So the very first thing, one of the first things we talked about today was targets, right? So your targets here are basically pointing to a compartment. So you can set up a target, and if you notice here, we are in the root. Okay. You'll see a bunch of different targets here, and these are all have been cloned from the Oracle managed targets. After creating a target, you would need to go to your recipes. And here's where we defined our different recipes here. And if you look here, you can see some of the Oracle managed ones here. This is a threat detector that's Oracle managed. So anything that's labeled Oracle managed are basically the out of the box recipes. Let me go to my compartment now. So I've got two recipes here. I've got a threat recipe. I've got an incident security recipe. If I go back to targets, you will see that I've created a target here, which is just basically my compartment. And the target, I've assigned the two different recipes. Here I've got a configuration type recipe. I've got an activity recipe, and then I've got a responder associated with my target. Now that I'm in this compartment, I can actually go to alerts, and I can take a look at the different problems that have occurred. So the problem, basically the name of the problem, the risk level, what type of recipe it was, and other information regarding that. So let's click on one of these. Let's take a look at the problem. Now you notice that I've got the name of the problem, and I've got these three buttons that we mentioned earlier. Two or three things you can do. You can mark it as resolved. You can dismiss it. Both of these are manual processes. You can provide a comment on each one of those. And remember, if you hit resolve or dismiss and you don't actually resolve the problem, the history up here will be updated in some cases, and in some cases that a new problem will be created. And then we also have a remediate button here. And since there's a corresponding remediate here, I don't have it listed here, but you would see the name, and you would have the ability to remediate the issue. Recipes, configuration. Now I'd like to go to the threat intelligence overview. Now, here's our threat intelligence database, right? And we talked about indicators. So you can select the different indicators that we support, right? So let's take a look at maybe an IP address. And you do a search, we'll search for everything. We have a list of IP addresses. We have information of the type. We have the threat type here. This is the correlation of the data. This is the MITRE attack feeds, what possibility this IP address can be associated with. And you have a confidence score. So if I click on this is very similar to the screenshot that we had. So this is the indicator. This is some details. Here's the confidence score. And then this is the history and where, the threat type. This is a suspicious, or this could be a SQL injection attack occurring. And based on this knowledge, you can make decisions upon how to control this IP from getting into your system. So that's all I have for the demo. I appreciate it. And now I think I want to hand this over to Amit. And Amit, take it away, please.
Thanks, Vinay. We move on to the final topic of today's presentation, which is container security. So let's look into the container security now. Container security enables you to store, share, and manage container images, such as Docker images, in an Oracle managed registry. It is not uncommon for the Oracle operating system packages included in images to have vulnerabilities. Managing these vulnerabilities enables you to strengthen the security posture of a system and respond quickly when new vulnerabilities are discovered. So you can set up OCI registry, that is the container registry, to scan images in a repository for security vulnerabilities published in the publicly available Common Vulnerability and Exposures database, like the NVD database maintained by NEST. You enable image scanning by adding an image scanner to a repository. From then on, any images pushed to the repository are automatically scanned for vulnerabilities by the image scanner. If the repository already contains images, the most recently pushed images are immediately scanned for vulnerabilities. Whenever new vulnerabilities are added to the CV database maintained by NEST, container registry will automatically rescan the images in the repository that have scanning enabled. So to perform image scanning, container registry makes use of the OCI VSS service, the vulnerability scanning service, and the vulnerability scanning REST API. And the steps are basically pretty simple. You first define a scanner, which is essentially has a very simple configuration. It essentially has the number of container images to scan when a suitable target is actually created using this recipe. And second part is defining a scanner. Defining a target. Target is nothing, but it is associated with one or more repositories in the container registry. And once the image scanning is actually done, you can view a summary of each scan, which will basically give you an overall risk score, the total number of vulnerabilities, and the number of issues at each level. And for each vulnerability, you can actually get the associated CV number and, where possible, links to the CV database, a risk score for that particular vulnerability, the date and time of creation, and so on and so forth. So let me actually, walk you down the console, show you the OCI registry with the repositories and the images, scanners, reports, etc. So basically the things we discussed until now. So here we go. So here I am having a container registry. I've gone into the dashboard, and it says the dashboard for the container registry shows, basically displays the number of repositories it is actually managing, the total number of images, under these repositories, and so on and so forth. So here under the repositories and the images, you will actually see the various various repositories and their images. So for example, the topmost repository, the OCI static site, it has about 53 images. So if I actually click on that, if I expand here, it shows you the various images, and each image has a version number, as you can see. And and when you if you for each repository, you can actually add a scanner from here. But as we discussed in the slide, you can a container registry's image scanning actually leverages VSS, the vulnerability scanning service, OCI's vulnerability scanning service. So basically, you go there under the scanned recipes for under the VSS. For the container images, you can actually define a new scanner. I already have a scanner here defined, and this scanner is basically telling you the number of images to scan for the first time. When the scanning actually is enabled for the target, which is again the scope of all the repositories. I mean, all the repositories you would like to actually scope. Similarly, once you define the scanner, you go back and define a target. And in this case, our target basically says that we have actually chosen all the repositories in this so-and-so compartment and all the compartments which belong to that under that compartment, the entire hierarchy, compartment hierarchy. That's a very simple step. So you basically define a target, or rather a scanner, and then define a target, which is basically the scope, which all repositories you would like to actually bring under its purview, and then you associate the scanner, with this particular target, and that's about it. And once this is actually done, and as I said, you can actually add the scanner for that repository from here also. But since I've already actually done that, I'm going to, we are actually all set over here. So let me look into the repository, into this particular repository, and let me look into one of the images. So here I am actually with the image, which is the version number 57 here. 57 image, and I can actually see all the scanned results. As you can see that the first first scanning was actually done on August 7th. Actually, that's the time when we created this demo. And the second one was actually created, or rather, second time the image was scanned was on August 10th. And you can actually go and look into the details. And as you can see over here, the issues found, there are 32 issues, and date and time when things were actually, when the scanning actually occurred, the risk level. And for each of these, each of these, it has detected various vulnerabilities, and each vulnerability is basically a CB, right? I mean, and as you can see the link below in the browser, you see the path to that information, which is taking you to the NVD, the National Vulnerability Database, which is maintained by the NIST, NIST. So this is what you get from the scanning and so on and so forth. It's a so that's kind of concludes my presentation on container security. Let me go back to the slide deck and here. So that kind of actually concludes our presentation on the 3 topics today. We discussed today OS Management Hub. We discussed Oracle OCI's Cloud Guard, and finally the container security. These are all useful tools and services which basically help you to monitor your environment and keep your environment very secure. And here are some of the resources on OS Management Hub resources. When you get the deck, they will have the links. And on the Oracle Cloud Guard resources, and finally on the container security. So that kind of ends our basically presentation. So over to you, Renu.
Thank you. Thanks, Amit. And thanks again, Vinay and Amit, for a great session. A lot of content that we covered today, but I'm sure everyone learned something new. Our next session will be part 2 of monitoring cloud security. Join us on Monday, September 16th to learn how OCI's robust suite of monitoring, logging, event management, and notification tools empower organizations to achieve continuous monitoring, performance, and security. I would recommend that you bookmark the Devon and Beyond page and check frequently for new sessions on trending topics, and we might add new series also there. So with that, thanks again for joining us. See you all next time. Have a great day, everyone.